Video is going to give you a little bit of an introduction to basic chemistry as we work our way into Unit 1A, which is going to eventually be talking about biochemistry. Much of this video should be review from hopefully things that you have learned in middle school. So we're going to start first with just a basic rendition of what an atom theoretically looks like and talk about some important vocabulary. So first, in your picture area, we're going to draw what's called the nucleus. I'm going to go ahead and label that nucleus. That is at the center point of the atom, and inside the nucleus we have two subatomic particles. We have protons and we have neutrons. And over here for our vocabulary, let's talk about that. The symbol that we just used for a proton is a lowercase p with a superscript plus sign. They have a positive 1 charge. And as we just noted, they are located in the nucleus. In addition to the proton, we have the neutron. Again, the symbol, a lowercase n with a superscript 0, also located in the nucleus. And you can guess that that 0 represents no charge. This is the central part of the atom. It is incredibly dense. It has lots of protons and neutrons in there, varying numbers. We'll talk about how we figure out how many protons and neutrons in a moment. And then kind of orbiting or circling around that nucleus, we have the third subatomic particle, which is called an electron. So I'm actually going to draw what kind of looks like an orbit. I'm drawing it as a dotted line. I want you to know that that is a three-dimensional orbit, so that electron can move kind of, if you want to think north-south, east-west, it can go in any direction as long as it's maintaining a particular distance away from the nucleus. And that line that I just drew, we refer to as an energy level. And on that dotted line, I'm going to put a lowercase e with a negative, being the symbol that we will use to represent an electron. And you can probably already guess that that negative means it has a -1 charge. And these are located in what's called an energy level. Sometimes we do call these orbitals because they are very similar to how planets orbit the sun. And in addition, I had mentioned that there's a particular distance away from the nucleus that does refer to an amount of energy that that electron maintains. As you get higher in your chemistry classes, you'll learn a little bit more about those energy levels and what that means for the electron. I'm going to go ahead and draw another energy level. Put another electron, maybe just randomly up here. Maybe I'll put another one in the first circle, this one being the outside energy level. I've got 3 E's there, and for our purposes, we're going to maintain that the overall charge on this atom is neutral. So if I have 3 -1 charges, I also need to have 3 +1 charges. So I'm just going to go ahead and draw some extra protons in there. We could put some extra neutrons. It doesn't really matter for our purposes. I just kind of want you to see that they're balanced. I also wanted you to note that the area between the edge of that nucleus all the way to the outer edge of the actual atom, this whole space right here is referred to as an electron cloud. And electrons can move from energy level to energy level. This would be the first energy level, the second energy level. We can go all the way up to 6 energy levels or so. And the energy amount that those electrons maintain depends on what energy level they're going to be located in. And again, that's really more for a kind of higher level class. But I do want you to know that a lot of this is really just empty space. These electrons are moving really, really fast around this tiny, tiny nucleus. And so honestly, we just have a lot of empty space up there. So kind of a little fact is that the majority of an atom is empty space. And I also want you to know that the mass of this atom While the electron does have some mass to it, it's really, really small in comparison to these protons and neutrons. And so the majority of the mass is actually located in the nucleus, and that nucleus is really, really dense. So the majority of mass, let me move my paper there, is in protons and neutrons. Electrons don't really have much weight to them at all. The bottom half, what I'd like to do in the bottom half of this worksheet is kind of talk a little bit really on how to read a periodic table. Perhaps at this point you have already color-coded your periodic table. We've talked about a few things on this, but I want you to be able to read those individual boxes. So you can see here I have a box with carbon. Carbon is the number one element in all living things, so naturally in biology class we're going to talk about carbon quite a bit. So we've talked about these vocabulary words in the picture above, but down at the bottom we have this vocabulary word of atomic number and average atomic mass. So let's go ahead and label those in our picture. First, let's start with the number up here at the top. This happens to be on the left side of the box. On your periodic table that I've given you, you'll notice it's in the center. It doesn't really matter. It is usually up at the top. It is a whole number, and this is the atomic number. So the atomic number for carbon is 6. And what that really means by definition is it's talking about the number of protons that are located in an atom of carbon. So every carbon of atom has 6 protons. As we mentioned up here, we had said that we're going to keep our atoms electrically neutral. So if we have 6 protons, then you're probably going to guess that we also have 6 electrons in carbon. I'll actually write that down here. But by definition, if you notice, I put the word protons there. We are going to learn that these electrons will move. They can even jump from one atom to a different atom, and so therefore a carbon might lose electrons, carbon might gain electrons. And so this number is the one that's always going to remain the same, and that's why by definition we say the atomic number is the number of protons. We have the letter C here. This is the chemical symbol for carbon. This one is an easy one. C for carbon kind of makes sense. It is just one letter, so it is capitalized. If we just kind of scan the periodic table, we'll notice that there are other symbols that have 2 letters. We'll notice that the first one is always capitalized, the second one is always lowercase, and for the most part they make sense. C for carbon, N for nitrogen, O for oxygen, B for boron, but some of them are a little bit different, like Na for sodium, K for potassium, even Mg for magnesium. And some of these that are really unique come from the Latin derivative of those words. So not all of them are going to be straightforward, but for the most part they are. You do not need to memorize the periodic table for my biology class, but you will start to get pretty familiar with some of the elements, especially carbon, nitrogen, oxygen, and over here on the left, hydrogen. Those are the most common ones we're going to see in living things. So we have C for the symbol, and then the word carbon just happens to be there. It's not always on periodic tables. I like to have it there because, like I said, we don't need to memorize anything for this class. And then that bottom number is a decimal, and that number represents the average atomic mass. And that is why it is a decimal, is because it is an average. Not all carbon atoms have the same mass. Some of the carbon atoms have more or less neutrons than average, than the normal carbon atom. What we're going to do with that number is we're actually going to use that to help us calculate the number of neutrons. What you do with this number, since it's a decimal, is hands down the first thing we're going to do is always round it. This number is actually the number of protons plus the number of neutrons. And since we cannot have part of a neutron, we're always going to round that number. We're going to use basic rounding rules. So the number after the decimal, if it's a 4 or below, we're going to round down or basically keep that number the same. If this is a 5 or higher, we will round it up. So 12.0, we would round to 12 or just keep it at that whole number. So if we have 12, and I know that this number is a combination of protons plus neutrons, and from this number up here, I already know the number of protons. I can subtract the number of protons, and I get 6, and that's going to tell me then the number of neutrons in the carbon atom. So carbon has 6 protons. I know from this number up here. Because I know my atoms are going to be electrically neutral, I also know carbon has 6 electrons. I take this bottom number, which is the mass, and I'm going to round it to 12, subtract my atomic number, and I can get my number of neutrons. For the most part, they're pretty straightforward. If we look at helium up here, for example, I see the number 2 up there, so I know I have 2 protons. I also know I have 2 electrons. My average number, 4.003, I'm going to round it to 4, subtract that number up there, I get 2, and I have the number of neutrons. Let me find one that has some different rounding. Let's look at oxygen down here. I've got 8 protons, I've got 8 electrons then, 15.9, that 0.9 is going to force me to round that up to 16. 16 minus 8 is 8, so I also know oxygen has 8 neutrons. The only one that's a little funky is hydrogen. If you look, hydrogen is number 1, a really, really small atom compared to the others. So 1 means I have 1 proton. It also means I have 1 electron. If I look at the mass, I have 1.00794. The 0.0 means I'm going to keep it at 1. 1 minus 1 is actually 0. And so therefore, hydrogen on average does not have any neutrons. That's the only one that's a little funky there. Hopefully this video kind of refreshes your memory and gets you a better idea of kind of the general structure of an atom, but also how to read boxes on the periodic table.